Hello and welcome to our video on using trigonometric identities to solve problems. Now I've put back our diagram here of the unit circle that you remember from previous videos. And just a reminder that the unit circle has a radius of 1 going all the way around. So this point here is 1, 0, 0, 1, negative 1, 0, and 0, negative 1. To go all the way around. We usually look at the point P in the first quadrant here, and we use our reference angle theta here. What we're going to go back to and think about now is that we looked at how the x value of point P is equal to cos theta. And the y value of point P is equal to sine theta. So we can say this side of the triangle is sine theta and this side of the triangle is cos theta. And we know by definition in the unit circle that this hypotenuse is going to be equal to 1 because it's the radius of the circle. If I could draw a 1. There we go. So just by using these things that we already knew, we can write that, and using Pythagoras, it's a right angle triangle, so this side squared plus this side squared will equal this side squared. C squared equals A squared plus B squared, that's Pythagoras. 1 squared equals sine theta squared plus cos theta squared. And a way we can write this, just a mathematical shortcut that mathematicians use, rather than putting it all in brackets because it is all squared, rather than putting it all in brackets, we will often use this notation. So this sine squared theta means the same as this. And you can do it with cos and you can do it with tan as well. 1 squared is 1. And that's one of our identities that we'll be using. Sine squared theta plus cos squared theta equals 1. And this can help us when we are rearranging our formula to try and solve problems. It might be useful to use this identity that we know. An example. Below. I'm going to give you two ways to solve this example. Two different methods, and you can choose which method works for you. The example is sine theta equals 5 over 13. If sine theta equals 5 over 13. And theta is between pi over 2 and pi. Find cos theta. So the first thing I'm going to think about is just drawing a quick unit circle. Pi is here, pi over 2 is here, so we're talking about an angle in this second quadrant. Sine is positive here, and we agree with that because our solution is positive. But cos is going to be negative, so our solution needs to be negative when we find it. First step, when we're using this method 1, using the trigonometric identity that we just learnt, first step is to write out the identity. Write out the identity. Sine squared theta plus cos squared theta equals 1. Second step is to substitute in 5 over 13, because we know sine theta is 5 over 13, so 5 over 13 squared plus cos squared theta equals 1. Cos squared theta equals 1 minus 5 over 13 squared. Which equals 144 over 169. cos theta will equal the square root of 144 over 169, which equals 12 over 13. Remember when we were right back here, we said sine is positive in this quadrant, but cos is negative, so we need to put a negative on our solution. The question is saying if sine theta is 5 over 13, find cos theta. Cos theta equals negative 12 over 13. That's method 1. Method 2 is about drawing your own triangles. So this is part of our unit circle. Here's our theta. This side is opposite, hypotenuse and adjacent. And we know from the problem that sine theta equals, let me check, 5 over 13. So sine is opposite over hypotenuse. Opposite will be 5, hypotenuse will be 13. We can then use Pythagoras to find this third side. So 13 squared equals 5 squared plus x squared. And you should get 144 equals x squared. X will equal square root of 144, which is 12. So this missing side is 12. If you know your Pythagorean triples, you know 5, 12, 13 is a Pythagorean triangle, just like 3, 4, 5. Once we have this side here, the question was asking us for cos theta. Cos theta is adjacent over hypotenuse. Adjacent is 12 over 13. And we just need to do our final unit circle check. We were going between pi over 2 and pi, so it's in this quadrant. Sine is positive, but cos is negative here. So we need to put a negative on there. Cos theta equals negative 12 over 13, and that should be the same solution we got for method number 1. You can use either method or both of them, depending how it helps you with the particular problem you're looking at. The final rule or identity that I want to just remind you about is that sine theta over cos theta is equal to tan theta. So that can be useful if you've got sine and cos and you're trying to find tan. Just divide them, or finding any of the others, use this equation. And it can help you work out some of your trigonometric problems. Thanks for watching the video today.